We know that the Big Bang Theory is widely accepted in the scientific community, but even so, there are still many people who completely disagree with it. How could the universe have exploded into existence? Of course, holding such a viewpoint is understandable. After all, it's ultimately just a hypothesis, an explanatory model about the origin of the universe. However, the reason scientists are willing to accept this hypothesis is not because they necessarily believe that the universe definitely came into existence this way. Rather, it's because based on the various pieces of evidence available, this hypothesis is currently the most reasonable explanation. To be honest, when the Big Bang Theory was first proposed, for quite some time, most scientists thought it was nonsense, similar to how some people doubt it today. How could the universe possibly have originated from a single point? But as more and more evidence started piling up, they had to reconsider and accept this intriguing theory. It's like what Sherlock Holmes said, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. However, when it comes to the question of the birth of the universe, we can't use the process of elimination. All we can do is temporarily identify the possibility with the most evidence. The initial framework of the Big Bang Theory comes from general relativity and is based on the cosmological principle of isotropy. If we simplify Einstein's field equations, we arrive at a significant solution called the Friedmann-Robertson-Walker (FRW) metric, also known as the Friedmann-Lemaitre-Robertson-Walker metric. Some might remember that we discussed this topic in the episode about gravitational sources. The idea of whether our universe will ultimately experience a Big Rip is related to this metric. After the introduction of the FRW metric, the American physicist Edwin Hubble observed that no matter which direction we look in the sky, distant galaxies exhibit a phenomenon called redshift in their spectra. This implies that these galaxies are moving away from us, suggesting that the space itself is expanding. Upon hearing this, Einstein visited the Wilson Observatory to see for himself. Initially, Einstein's field equations predicted a dynamic universe, but due to his philosophical beliefs, he introduced a cosmological constant to force a static universe. However, when he saw the evidence of cosmic expansion, he regretfully called this addition the biggest blunder of his life. Later, luminaries like Einstein and Eddington gradually abandoned the static universe model. However, even before this shift, a young scientist, Georges Lemaitre, firmly believed in the expanding universe. Before Hubble's discovery of cosmic expansion, Lemaitre had already estimated the Hubble constant. In recognition of Lemaitre's contributions, the International Astronomical Union renamed the Hubble constant to the Hubble-Lemaitre law in 2018. As Lemaitre's theory finally gained practical validation, he made a further hypothesis. Since the universe is expanding, if we trace back in time, it should have started as a single point. He speculated that today's universe might have expanded from that point, which he termed the primeval atom. This idea could be considered a precursor to the later developed Big Bang Theory. In the 1930s, just before World War II, nuclear physics was a hot topic, especially research related to atomic bombs, which spurred the field's growth. Another young physicist, George Gamow, originally from the Soviet Union and later settled in the United States, applied quantum mechanics, at its peak, to the field of cosmology. He assigned his student, Ralph Alpher, to research the theory of element synthesis during the early stages of the Big Bang, contributing to the development of the hot Big Bang cosmology. Alpher's calculations led to the inference that the universe began in an extremely high temperature state, cooling gradually as space expanded. By today, this temperature should have cooled to around 5 Kelvin, which also provided an early prediction for the cosmic microwave background radiation. The mainstream scientific community initially regarded this theory as a joke, especially since it was published on April Fool's Day. Furthermore, the term Big Bang for this theory was not coined by Gamow's group, but rather came from the opponent of the theory, Fred Hoyle. Hoyle and his group proposed the competing steady-state universe model. Note that the steady-state model doesn't imply a static universe but rather a universe in constant expansion without a beginning or end. In a BBC radio program, Hoyle first used the term Big Bang. Many thought Hoyle originally used this term as a mockery of the theory, but it eventually caught on due to its evocative nature. Hoyle later clarified that he didn't intend that meaning and only used the term to emphasize the distinction between the two models. So, which of these vastly different theories is more reliable? The quality of a theory is ultimately determined by its practical testing. The final nail in the coffin for the steady-state universe theory was driven by one of the 4 fundamental discoveries in astronomy, the cosmic microwave background radiation. The discovery of this radiation has its own legendary story. Previously, Alpher, a student of Gamow, calculated the initial super-high temperature of the universe. After expanding and cooling over time, this background radiation cooled to about 5 Kelvin by today. However, due to technological limitations at the time, it was difficult to observe such low background temperatures. It wasn't until the mid-1960s that 2 radio engineers at Bell Labs, Penzias and Wilson, while trying to measure the performance of satellite antennas, stumbled upon a persistent noise that they couldn't eliminate. They even cleaned off bird droppings from the antenna, but the noise remained, and it was uniform in all directions in the sky, irrespective of time or season. They published their findings in a paper in the Astrophysical Journal. Around the same time, other physicists were also trying to eliminate similar noises, and they realized that the noise they were trying to get rid of was actually the thing they were looking for all along. Penzias and Wilson's paper was published before others, leading them to receive the 1978 Nobel Prize in Physics. The temperature of the background radiation they measured was about 3 Kelvin, very close to what the Big Bang theory had predicted, strongly supporting its validity. Additionally, predictions and measurements related to the abundance of light elements in the universe and the measurement of baryon acoustic oscillations further improved the credibility of the Big Bang theory. Before this, scientists opposing the Big Bang theory began to admit that it was valid. However, Hoyle remained stubborn, and even until his death in 2001, he didn't believe in the Big Bang theory. To summarize, people initially thought the universe was static, but Hubble's observations revealed that the universe is expanding. With the discovery of the cosmic microwave background radiation and other compelling evidence, people started to believe that the universe might have indeed originated from a Big Bang. However, it's important to note that the Big Bang explosion in cosmology is fundamentally different from our everyday understanding of an explosion. In regular life, an explosion occurs within an existing space, while in the context of the Big Bang, the explosion itself marks the beginning of space. Hence, the question of where the singularity of the Big Bang occurred doesn't apply, as the entire universe we observe today expanded from that singularity. Finally, about the Big Bang theory, it's crucial to emphasize that many attempts to use the theory to speculate about what happened before the Big Bang are essentially meaningless. As Alan Guth, who later proposed the inflation model, noted, the Big Bang theory doesn't explain the Big Bang itself. Instead, it describes the series of outcomes that resulted from the Big Bang. Therefore, it cannot answer questions like why the Big Bang occurred or what happened before it. It's more focused on explaining why the universe appears as it does now. So, that's a summary of the history and details of the Big Bang theory. In the next episode, we will explore what the universe went through during the Big Bang period.